Okay, so we are going to be looking at oblique collision between a sphere and a fixed surface. So we are going to start with case 1. Okay, we are going to start with case 1. So for case 1, in this case we are dealing with a vertical surface. Okay, for this case we are dealing with a vertical surface. So we have a vertical surface, all right. Then we have a sphere. The line joining the center of the sphere and the vertical surface is horizontal. Then we have the sphere moving towards the vertical surface with an initial velocity of u. So this initial velocity is u, and then there is an angle made with the plane of the surface, which is theta. Now the sphere rebounds. Okay, so here's a sphere rebounding. Let me do something better. So the sphere rebounds, okay, with a final velocity of v. Okay, and then we also have to resolve horizontal component and vertical component. All right, now here we need to resolve this into vertical component and horizontal component. So what's going to be the horizontal component? Just look at this right angle triangle here. Okay, if you look at it, you see that if you do cos theta, you get opposite on hypotenuse. So what is the opposite? Sorry, cos theta is adjacent on hypotenuse. So what's the adjacent? U cos theta. So what it means is that this vertical component here is u cos theta. Okay, u cos theta. Then the horizontal will be u sin theta. By default, the horizontal will be u sin theta. Now after collision, you have to note that the component that remains in the same direction does not change. So this vertical component is in the same direction, upward, so it stays as u cos theta. Okay, and then the horizontal component changes. We can call it x. All right, we can call it x. Then now we need to apply the Newton's law of restitution. Okay, so Newton's law of restitution says that the coefficient of restitution between the wall and the sphere is equal to velocity of separation. So first of all, our reference frame is like this. If you're going to the right, the velocities are positive, so going to the right implies positive, going up implies positive, going to the left implies negative. Okay, going to the left implies negative, and going down also implies negative. So if I apply the principle of conservation if I apply the Newton's law of restitution along the line of centers, E is equal to velocity of separation, which means their final velocities along the line of centers after impact. So if I do v wall, I'm going to subtract v of the wall, v of the sphere after impact along the line of centers. The line of centers is horizontal, so we are talking about this horizontal velocity. Is it okay? But since it's pointing to the left, it is negative. So v wall minus negative x, v wall minus negative x divided by, I will now start with that for the sphere, which is u sin theta, is going to the right, is positive, minus u wall. Now v wall is equal to 0 because the wall does not move after impact, and u wall is also equal to 0. Okay, so this is going to help us to get our vx. So you are going to get E is equal to x over u sin theta. So it means that what is x? X is EU sin theta. Is it okay? Voila. Now if you want to find the velocity of the sphere after impact is given by the velocity along the x, which is minus x in the I direction. We are putting minus because our x is moving to the left, and then moving upward is u cos theta. Remember, velocity is a vector, plus u cos theta in the j direction. That is the velocity. So we are going to get minus eu sine theta, because that is x in the I direction, plus u cos theta in the j direction. So this gives us the velocity. Now if you're asked to find the speed is equal to the magnitude of the velocity, which will be the square root of minus eu sine theta all squared plus u cos theta minus u cos theta man, the pen doesn't want to come out, all squared. Then we simplify, you're going to get your answer. Is it okay? Voila. So that is it. So this is our first scenario. Now in our second scenario, we are going to look at in our second scenario, we are going to look at in a case where the wall is horizontal. Okay, so in a case where the wall is horizontal, this is what we have. We have a horizontal wall. Okay, we have a horizontal fixed surface, and then we have a sphere moving towards it. Okay, so we can have a sphere like this. All right, this is a line joining the center of the sphere, and the wall is vertical this time around. The sphere is moving towards the wall, which makes an angle of maybe alpha. Then it's moving with a speed of u. Then it rebounds. All right, it rebounds, and then when it rebounds, it has to be moving towards the right and downwards, because the final speed is v. Is it okay? So now let's first of all resolve for this initial. So for the initial, you are moving like this and you are moving like this. Okay, so let's get the two components. Just think about this right angle triangle that you see here. If you do sine alpha, what do you get? You get opposite. The opposite to alpha is maybe what you're looking for divided by the hypotenuse. So what is the opposite? U sine alpha. So this is u sine alpha. Then this is now u cos alpha. Okay, now after impact, I've said that the direction that does not change is a direction that remains still. So you see that the left still moves to the left. So this is u cos alpha. All right, it does not change because you see that the direction is maintained, but you see that the vertical direction is reversed, so we are going to call it y. Then we still use the Newton's law of restitution. So Newton's law of restitution says that E is equal to velocity of separation, which if I do v wall minus, now what is the final velocity of the sphere along the line of centers after impact? The line of centers is vertical, so after impact the final velocity that is vertical is y, but it is moving downward, so minus y. Okay, divided by the difference of that initial velocity. So since I started with v wall in the numerator, I will start with that of the sphere, and you see that along the line of centers the initial velocity of the sphere is u sine alpha. Okay, because that's why it's along the line of centers. So you have u sine alpha minus u wall. But we know that v wall is equal to 0 and u wall is also equal to 0. All right, so it therefore means that E is equal to capital Y divided by u sine alpha. So what is capital Y equal to? It is eu sine alpha. Okay, voila. So if I ask you to find the velocity vector is equal to the velocity along the x. What is the velocity along the x? It does not change. This is it. Okay, but it is negative because it is pointing towards the left. So you are going to have negative u cos alpha in the I direction, then plus the velocity along the y, but along the y is pointing downward, so it's negative, so minus capital Y in the J direction. So this will give us minus U cos alpha in the I direction minus what is Y. We have seen that it is EU sine alpha in the J direction. If I ask you to find the speed, okay, the speed which is actually this V that I wrote here, the speed, here's the speed. The speed is actually this V. Okay, this is my speed. So the speed will be equal to the magnitude of the velocity, which is going to give us a square root of negative U cos alpha all squared plus negative EU sine alpha all squared. You get your answer. All right. Now the third case, in our third case, we are going to combine the two motions together. Okay, in our third case, we are going to combine the two motions together. We are going to look at both motion with a vertical wall and motion with a horizontal wall. So imagine that I have given you a sphere. Imagine I give you no, let me take the dark coloration. Well, let me see. I'll take black. Yes. Now imagine that I give you a sphere that collides with a vertical surface and then collides again with a horizontal surface, and ask you to get a final velocity of that sphere. So what happens is that this is what you're going to get. You're going to first of all analyze. When it is going towards the horizontal, the vertical wall, it moves with a velocity of, with a speed of u. Then when it rebounds, it has a new speed. I'll call it v1. And then when it rebounds again, it has another new speed. I'll call it v2. Is it okay? Now we can have an angle of maybe theta here. Alright, we can have an angle of theta there, then we have to analyze. So in this situation, we are going to analyze in different cases. So for case one, we are going to analyze when it was colliding with a vertical wall. Alright, so here we have U, we have the sphere moving here with U, alright, making an angle of theta. If the theta is given to you, you just use the theta that is given to you. Let's get a vertical component initially and the horizontal component initially. Then when you rebound with v1. Alright, now when you rebound with v1, we need to resolve v1 into the horizontal component and the vertical component. But we know that the vertical component of v1 is the same as the vertical component of the original, because you see that direction initially and after is still going up, but the direction that has reversed is the horizontal component. Okay, so this man is u sine theta, and this man is u cos theta. So this man is going to be x. Okay, that's going to be x, and then this stays as u cos theta. Alright, voila. So let's get our final v1. So if we use Newton's law of restitution, we are going to have E is equal to the velocity of separation. So if I do v wall minus the v of the particle, which is now negative x, divided by u of the particle, which is u sine theta, minus u wall. So what is x? X is going to give us EU sine theta. Is it okay? Now what is now the velocity? So v1 as a velocity is equal to the velocity along the x, which is minus x because x is going to the left, plus the velocity along the y, which is u cos theta in the j direction. If you check the diagram, you realize that that's it. Okay, so that's the velocity. Now when you are going now to collide with this second wall, like when you're coming here to collide with the second wall, you are actually moving now with v1. Okay, when you're going to collide with that second wall, you're moving with v1. All right, so we are going to now analyze using v1. So case 2, so that's case 1. all right, so we have gotten case 1. If you ask you to find the speed, you just find the magnitude of that velocity, you will get the speed. Now for case 2, this is what is happening. We have, for case 2, we have the horizontal wall, okay, but when you're moving towards that horizontal wall, you're moving with a velocity, you're moving with a speed of v1. So when you're moving towards this horizontal wall, you're moving with a speed of v1. Is it okay? Now moving with this speed of v1, here's the center of the sphere, the line of centers is vertical this time around. We need to resolve. In fact, there's no even need to resolve because we already know what v1, the components of v1. If you check very well, just come back to the previous diagram, you see that v1, the horizontal is x, okay, so this stays as x. All right, then what about the vertical? The vertical is u cos theta, okay, so this man stays as u cos theta. Is it okay? So that's v1. In fact, if you just check this previous step, you realize that your v1, the x component is minus x is going to the left, the y component is u cos theta. Okay, then when it rebounds from the wall, it now leaves the wall with v2. all right, it now leaves the wall with v2. So here is it. So v2, you'll be moving to the left and you'll be moving downward as well. So you're leaving the wall with a speed of v2. Is it okay? Now you see that since x is still to the left, x does not change. All right, and then what happens is that the vertical component is going to change to y. All right, now we also need to apply Newton's law of restitution. So Newton's law of restitution says that E is equal to velocity of separation along the line of centers. All right, our line of centers is vertical. Okay, so the velocity of separation along the line will take the final minus the initial. All right, so we'll take the difference of the finals. So if I take v wall, what is v wall? V wall is 0 minus v of the sphere, which is negative y because y is pointing downward, divided by u of the sphere. What is u of the sphere? It is u cos theta because that's the initial along the line of centers when we are going towards the wall. So you have u cos theta, then minus 0. Okay, so from here, what is y equal to? Is eu cosine of theta. All right, so it therefore means that my final velocity is velocity along the x, but x was going to the left, so minus that plus along the y was going downward, so minus. So this gives us minus eu. Now let's go to x. What is x? Our x is eu sine theta. In fact, here we will just write minus eu sine theta in the I direction plus u cos theta in the j direction. That's the velocity. So my sine is eu sine, my x is eu sine theta, but there's a minus here, so minus eu sine theta in the I direction minus, what is y? What is our y? Our y is eu cos theta in the j direction. Yes, that is it. So it therefore means that if I ask you to find the speed, okay, the speed is a magnitude of the velocity, which is just the v2. all right, so what are you going to do? You are going to have the square root of the first component squared will be e squared u squared sine squared theta. The second component will be e squared u squared cos squared theta. Okay, then now you realize that e squared u squared is common, so you have the square root of e squared u squared. Then you're going to be left with the square root of sine squared plus cos squared, which is 1. So the final answer of the speed is e times u. Is it okay? So that's how we analyze motion between a vertical wall, then a horizontal wall later. So now I think you know how to analyze motion between it's between a sphere and another sphere, which means that if you're given a problem where you have, if you're given a problem like this, if you're given a problem where you have a sphere colliding with a vertical surface first of all, then colliding with a horizontal surface thereafter before meeting another sphere, you have to analyze. So imagine that you have a sphere here, okay, line of center to the wall is horizontal, collides with this man, then rebounds to collide with this man, then from there it rebounds again. No, this is not good. From there it rebounds again. No, this is not good as well. Let me use a dark. From there it rebounds again, and then at the moment it is leaving, there is another sphere that is launched such that their line of centers is horizontal. Okay, so it will be easier for you to analyze, because at the end of the day, when you want to analyze the collision between these two spheres, you will have to use the final velocity of this sphere, which is v2, analyzing with the initial velocity of this sphere here. Alright, then you start now analyzing the motion between the two spheres. So that is it for the video. See you guys in the next video.